It is given that T1 and T3 are in arithmetic progression. So find ratio of thermal conductivity of the two sheets, this and this. The length is D, then is 3D. Here temperature T1, temperature T3 as given in the question, and T2 is arithmetic mean of this temperature, of these two temperatures. So arithmetic progression means T1 minus T2 is equal to T2 minus T3. We have studied that, na? Difference is always same in arithmetic progression. That is what they are trying to say. So T1 minus T2, T1 minus T2 is equal to T2 minus T3. That gives us T1 plus T3 is 2T2, or T2 is T1 plus T3 divided by 2. So we got actually T2. Directly also you could have written that this is the mean temperature of these two. Now as heat flow rate is constant throughout, we get, because these two rods are in series. So whatever heat goes through in also goes through the second rod and comes out. So K1A T1 minus T2 upon D. Okay, this is the distance, and K2A T2 minus T3 upon 3D. Now D gets cancelled. I get K1 by K2 as T2 minus T3 upon T1 minus T2 divided by 1 by 3. Okay, so I'm now putting the value of T2, that is T1 plus T3 divided by 2 minus T3. Okay, then in the denominator T1 minus T2 again, T1 plus T3 divided by 2, and 1 by 3 is as it is. Now you can see that K1 by K2 becomes on solving we get T1 minus T3. Here also I'm solving, I'm getting T1 minus T3. So this gets cancelled and only 1 by 3 is left. So final answer of K1 by K2 is 1 by 3. So they formulated it in a way that it's easily calculatable, and this gets cancelled. Ultimately we get K1 by K2 as 1 by 3.